It's time to get started. Can you hear me? Good morning. Third day of the conference. It's been a long week. I'm glad that you're still here. I'm glad that you chose this talk. So let me introduce myself first. I'm Felipe Hoffa. I'm a developer advocate at Google. Do you know what a developer advocate is? No? A developer advocate is basically a software engineer with a license to speak. And I've been doing this job for the last 6 years. I started at Google 8 years ago as a software engineer, and then I took this role as a developer advocate that gives me the ability to go to conferences, travel, publish interesting blog posts on Twitter, on Medium, on Reddit. You can find me everywhere. And today we're going to talk about protecting sensitive data in huge datasets. So I guess you are all interested in privacy and what can we do to protect people's privacy, while at the same time maintaining the balance with the utility. Now, I was wondering, just on this first slide, how much PII can you find here? First, there's my name there. That's PII. If I wanted to protect my privacy, I might want to remove my last name and remove my Twitter handle. And now I'm way more protected. Or not really, because you still know that this is a Felipe, a developer advocate at Google. You can still find me, so I can start redacting more and more information. What if I'm just Felipe that talks about big data? Am I protected now? Yeah, you're saying no, because? Because yes. So for example, if we go to Google and we look for Felipe Big Data, that is me. And yeah, I'm here on videos, I'm here talking. And yeah, the other problem here is that the name Felipe is not a very common name. So depending on which country you go, but at least on the big data world, apparently I'm the one Felipe talking in public. So the first ideas here are like, you might want to redact data. You might think that leaving first name only is OK. But there's a lot of statistical considerations. Do you have a common name? Do you have more data there that if you put those things together, a name and a subject, will that reveal who you are? Or not? If I was a John doing big data, maybe it wouldn't be that easy to find me on Google. So the first question is, how do we balance the data utility and risk? Because at the end of the day, I don't want to protect any of this. I want you all to know that I'm a developer advocate, that I work at Google, that you can find me on Twitter, and I would love you to follow me. So even though I might be protecting my privacy, I really want to reveal all of this data. Another example. This is me going to give a talk in Berlin and checking the night before how long will it take for me to get there to the venue. 20 minutes, OK. I set my alarm 30 minutes before the talk. I will get there on time. But the next morning, we don't have the same situation. Of course, during the day, instead of taking 20 minutes to get wherever I'm going, it's taking 40 or 30, wherever is happening at that moment. And the question is, how could I have predicted this? What tools can you use to predict how long will it take you to get somewhere tomorrow, or when it's raining, or when it's snowing? You can use Google Maps, maybe. But then you're depending on Google Maps and having that feature. What if we had data available? This is, for example, a map. Do you recognize this place? Yeah, this looks like Manhattan. The funny thing here is this is not a map. This is a plot of a lot of latitude, longitudes of every taxi trip people were taking during a year. There's more than, people take like 170 million taxi trips a year, and New York made this data public. I have the latitude and longitude of where the trip starts, where the trip ends, at what time. So I can start plotting and analyzing things. Like, I built this map with a SQL query, and now it's really, really interesting for me because I can start running my own predictions and using this data for my own purposes. So, for example, this is a different chart looking at the number of trips depending on the hour of the day. Are these short trips, long trips? And you can see a breathing city, and you can look at, you can run a different query, like tell me how long it takes to get from point A to point B during a rainy day. And now I can run my own predictions. I'm really, really happy that New York releases data. This is not all interesting as exercises in big data like this one. This can also help improve policy different cities. For example, here you can see in the blue line is the number of taxi trips that people are taking in New York per hour. And you can see this big dip at 4 p.m. Do you know why we have this big dip? Why would people stop taking taxis at 4 p.m.? No, this is it's not a special day. This is an average throughout the year. At 4 p.m., people stop taking taxis. Hmm? They're having a nap? No, the thing is, the problem is not that people want to take less taxi trips. The problem is the regulation in New York. And the regulation is not sending all taxis home at 4 p.m. The regulation only says no taxi driver can be driving for more than 12 hours. And that's a pretty good regulation. Like, you don't want a driver driving for you that has been awake for 20 hours. And so every 12 hours, they give the taxi to someone else. And that's all good. The problem is that everyone decided that they will go home, they will do this shift change at 4 p.m. So everyone goes back to their stations, they exchange the taxis, and everyone leaves. And then it turns out a regulation that had a really good purpose means that people cannot find taxis when they want to find taxis. And the question is, well, first, thanks to having this public data, is we can see this. And using this data, the question is, can we find alternative policies? Can we do something? How can we change this? And public data is allowing us to see this. Now, you may wonder, is it true that people don't want to take taxi rides at that time? On the red line, you can see the same curve, but instead for public taxis, this is for private companies like Uber or Lyft. And you can see that there is no dip at 4 p.m. And this is in 2015. Then in 2016, you can see how Uber, Lyft, and others grow, and now they have the same number of rides than the taxis. And the taxis still have this problem at 4 p.m. And then in 2017, you have even more rides for Uber and Stimulus, and taxis are still having the same problem. So at least we have the public data to show that we have this problem and to devise some solution. That is really good, and I love data, and I love analyzing data, but on the other hand, you start having articles like this. New York releases data, now fully anonymized logs reveal New York City cab drivers' detailed location. Turns out you can track each individual driver, which is good if you want to find the best incentives to have them not change their shift all at 4 p.m., but they might feel their privacy violated, or you were able also to follow a celebrity. If you saw someone taking a cab outside Radio City Hall at 4 p.m., you know the license. Even though the license was hashed, you were able to kind of know where they got after taking that trip. So there is a privacy problem, and the question is, how do we solve it? How do we find the balance between protecting people, protecting their privacy, but also on the big value of having open data, enabling innovation, enabling people the knowledge that this data brings. So one possible solution is just locking everything up. Let's not do public data anymore. It solves some problems, but there is a balance. There's a lot that you can do in the middle, and the question is, where do you find that balance? Rich data sets with all the data included are really, you can get a lot of value out of them, but you might want to maybe de-identify them, or aggregate data, or instead of publishing real data, publish synthetic data. It's fake data that looks like normal data, but at least you cannot find anyone. Or you can delete everything, call it a day, and then the question is, where is the balance? I cannot tell you where the exact point is, but at least I can give you some ideas. I can give you some tools that we use at Google. So if you want legal advice, don't ask me for legal advice. If you're interested in GDPR, these two gentlemen were previously at NDC giving really interesting talks, giving out their viewpoints. You can find their videos, developing privacy with Glenn, and privacy and GDPR, what all developers should know with Johannes. And they allowed me, and they gave me their consent to take this picture and share it with you. What's really, really interesting when you get GDPR experts together is that they both will tell you that GDPR is super, super easy to solve, but then you put them together and you ask them questions where their opinions might differ, and it gets really, really interesting to see that at the end of the day, complying with GDPR is not easy, and there's a lot of subtleties, and it's really, really interesting to see both of them discussing. So let's go back to some ideas and tools that we have at Google. You might know of the company I work for. We have several products with 1 billion users. We have to comply with a lot of regulations around the world, including GDPR. So we have developed tools internally, and now we also, as Google Cloud, we want to make them publicly available. So let's talk about some techniques to reduce risk. Let's say you are developing a chatbot. This chatbot is helping people fulfill their prescription orders. And if they want to fulfill their prescription orders, they might need to give you their name, their credit card number. They will give you their date of birth for identification purposes, their social security number. And this is all good if you want to help them. The problem is, what do you do with these messages internally? Yes, you need this data to serve people, and you also might want to analyze this data. Your analytics team has a lot to learn from what people are doing, and the question is, what can we do here? Because you want to share this data with teams, you want to do analytics, you want to do machine learning. So the first thing we need with a message like this is we need to identify what is PII. We might want to redact PII, and we also want to measure the remaining risk here. And we happen to have this first internal API that now is a public API that anyone can use. It's called Cloud DLP, that will allow you to discover PII, classify it, do the masking, measure ID risk, and do all of these different tasks. Can you use it in your own pipeline? Are you allowed to do it? That's a question for your lawyers, for your compliance department, but we do comply with a lot of worldwide regulations, so the question, probably yes, you can use it. A lot of what this API does, at least when you're using it in streaming mode, it never stores data. Everything is on flight, so at least you can rely that data is not stored. And it has at least 90 classifiers for many countries of different PII that you can find. And you can also not use it only to identify PII. Once you find PII, you can define rules. How do you transform your data? Do you want to do reduction? Do you want to mask? Do you want to add pseudonyms, tokens, format-preserving encryption, date shifting, more? And it handles, as you can see, this is a table with data. It can transform structured data as well as unstructured data. Even pictures. We love giving this demo at conferences. I don't know if a credit card number is PII, but you might want to redact it. This API is able to also look at pictures, find the sensitive data, and mask it, not only with credit cards at conferences, also if you have a form that people are sending you fax, or you have documents that you have scanned, you can also go through these documents, identify PII, and mask it before further sharing. Then you might want to identify risk, see how risky your data is. So for example, if you have a survey and you only leave the role of people, good. Software engineers, there's a lot of software engineers, so we're protecting their privacy. But if someone says that they are the CEO at Google, then there's only one of them, or maybe like 5 now, depending on how you look at my organization. but there is a different risk, and you want to measure it, and the API is able to measure it too. So you have some outliers, you want to identify them, and you want to show them off. Doing some generalization and bucketing is also really interesting. Instead of having the role for the specific role for each person, instead of having that someone is a senior engineer, we can make everyone that looks like an engineer, and everyone that's an operations manager a manager. We start covering cases like this. You can even do some date shifting. So for example, for the taxi trips, or let's say we have hospital records. When people enter the hospital, you want to protect their privacy, you might want to make the date, to fuzzy the date a little, move it some days forward or backwards. And then the problem when doing analytics over this is what happens if you reverse the order. Now that we did some randomization on the dates, would have preserving the order of the events for one person is also important, and the API is able to do this. Date shifting in context. And even if we don't have all of the, if we don't have predefined detectors for every type, you can define your own. This would be using the API. How do you tell them, use this regular expression to find this kind of data? And you can also add a likelihood qualifier. If something looks like this, it might be a social security number. You can also add a little more of information for custom detection. You can say, if this regular expression is close to this other word, then the likelihood of this being PII increases or decreases, and you can start running your own logic. Or you can even define dictionaries. This is not easy to implement, but we managed to implement it, just having dictionaries with millions of entries and being able to detect any of those in your documents. For example, if you want to tokenize data, let's say you have an employee ID and you want to transform it for an employee ID that looks like the original one, but it's not. It's encrypted. You can define rules like this. Do a crypto replace, and use the alphabet, a numeric alphabet, so the data ends up looking similar. And then, again, you can do a re-identify operation if at any time you need to get that data back, because that's why we would encrypt data instead of masking it. And here I have the key, and I'm showing the key, but you can also use a key manager, so everything is super secure. And then you can do automated identification. So for example, for the same message, if we are going to propagate it around our company, instead of showing the straight message that we got, our analytics department might get, hi, my name is person name, my card number is, you can see that the credit card number has been encrypted here, the social security number has been replaced. Let me show you a demo of this, just to show it. Let me see if I can show this working on real time, depending on our Wi-Fi. So for example, I can say, hi, I'm Felipe Hoffa. I live in San Francisco. My company is in 345 Spear Street. And you can see that somehow, well, it's not perfect, so I don't know why. Oh, yes. Maybe I had not pressed enter. But you can see that all of these reductions can be run in real time, and it works. Even if I say, hola, if I use it in other languages, yo vivo en San Francisco, mi dirección es 345 Spear Street. And yeah, you can see it working in different languages. I would love to test this in Norwegian, but I don't speak any Norwegian other than tak. So we will leave that for a different moment, but please experiment with this. Now, let's talk about the same, not in a streaming dataset. This was live. What if you had a huge existing dataset? In this case, my example It comes from Wikipedia. They are running this huge experiment of how we make more civil conversations, especially on the talk page when people are discussing what an article should contain. Sometimes those conversations are not very civil, and so Wikipedia has been working with Google to find ways to make the internet a better place. And they have this data set with 95 million user and article talks, like all of the conversations that people are having, and they have been rated. Is this a conversation toxic or not? And part of it has been done with machine learning, but the originating training data set has been annotated by a crowdsourced to see if the messages were civil or not. And I have this table stored in BigQuery. It's a 290 gigabytes table, 240 million rows of raw conversations. And the question is there any PII here or not? Do you know what BigQuery is? OK, so quick, what is BigQuery? BigQuery is our cloud data warehouse. It's fast. It analyzes terabytes in seconds. You only need to know SQL to use it. It scales really, really easily. Like, you really don't need to do anything to go to petabytes, but you can use it with small tables too. There's nothing to turn on. It's always on. You don't have to pay per hour. You just pay per query. And you can use it with different tools. They all connect to BigQuery, Tableau, R, Python, Looker, Data Studio, Power BI. And two things that are really cool about BigQuery is that you can share data with it. If you have your own tables there and you want to share it with third parties or in public, you can just do it. So I have some tables shared with everyone. And everyone gets a free terabyte every month to run your own queries. Now, let me show you this table that I have with Wikipedia data. This is Wikidetox. This is my external copy that I can share with you. I have not shared it yet, but I've been approved to share it. I have been approved. And you can find that this table has a lot of data. It has the comments. It has this is the values that have been calculated of how toxic this conversation was. 290 gigabytes of data in 240 million rows. And if you want to see comments, here we have some samples. Hello, please do not remove the redirect to this article. And someone here is angry. I hardly think I'm vandalizing your page by posting a warning about your constant reverting of pictures. So you can see that you start having discussion here. But the question for this talk is not how toxic this conversation was, but how do we find PII here? How do we find sensitive data that we might want to redact? And it would be really easy, at least with DLP. You can just click Scan with DLP. And it will go through your whole file depending on the instructions that you give it. So in this case, instead of having files, I have a table. And I might want to do a full scan or sample just some part of it, 10% of the whole thing. I can see what fields are identifying. I want to use them as an identify field. So let me skip that part. You can configure detection. These are all the info types I want to look for in this data, or these are my custom info types. These are my rules for inspection. This is the confidence I want to have. It's very likely PII to, maybe it's not, and you can add actions, etc., of what you want to do with it. And then after you start running that job, you will find all of the PII detected here in a new table. And this table has a lot of data. So let me run a query here to show you some of the findings that we got from this data set. So in this case, this query is going through all of the findings that I got. And I'm looking only for the very likely PII. I want to find 7 examples of what kind of PII it found of each type. And my results are here. Where are my results? There you are. So yes, sometimes people are talking about their age. And how do you see that something is an age? age of 15, 20 years old. So they are giving me a range here. But there are many ways of how people talk about age. We can find it. Things that look like credit card numbers, things that look like a date of birth. It can look like a date, or someone might have written it, or email hardware IDs, IP addresses, MAC addresses, Swift codes, or things that look like Swift codes. We can find PII, we can find all of this data, we can detect it, and then we can decide what we want to do with this. In this case, this data is shared publicly anyways. But even if you have permission to share this PII, you might want to remove it. For example, if you want to train a machine learning model. It makes a lot of sense for this model to not learn PII, but just learn what's around it. Any questions about this before I go to the second part? Are we doing fine? Then what do you do with this data once you have identified the PII? I will not go deep on this, but we have a full example and video of how you can process all of your files and all of your tables. And with the DLP API, decide, OK, once I find this, I want to replace it with an email address. If I find an email address, I want to tokenize it or do my custom info types and do this, apply these templates for de-identifying data, or run these buckets, etc. And once you have defined that, you can run all of this, and you can have your de-identified data sets ready to be used. And the important question here is, when do we stop? When are we done with the identification? I want to share a data set. How much anonymization should I do? How do we measure this? And that's the next part of the talk. First, let's go back to some definitions. There is PII, identifiers, my name, my credit card, my government ID. Those things uniquely identify myself. But there are some, and you might want to remove those immediately. But what do we do with quasi identifiers? Do we publish my job title, or my zip code, or my age? Depends. There is a risk on revealing those quasi identifiers. Now, why do we have risk? Why are we doing this de-identification? Is because we care about sensitive data, health conditions, or I want to protect my salary in a survey, or I want to protect what I said about my manager in a survey. And once we have defined these three concepts, we can proceed to measure. And there are different measures of how risky is the identified data set. We have our API will calculate k-anonymity, Eldiversity, Kmap, and delta presence. And let me go a little on depth here. K-anonymity is a property of a dataset that indicates the array identifiability of its records, and it measures how many individuals are in a group of data. So we are aggregating, and then if we have aggregated data, but we have only one person in one group, then that person might be super identifiable. And I will show you this example with Mexico's birth. These are all babies born in Mexico. This is a public data set with around 13 million babies born until 2013. And you can find a lot of data here about the baby and also about the mother. I have this as a public table in BigQuery. And you first, for example, you might want to see how is the data distributed. You might want to do some cleanup. And the question is, what can we find in this data set? So let me run a query here. I had it ready. These are my Mexican birth. This, you can see that it has a ton of columns with maybe sensitive data. It's private. It's pseudo-anonymized because we don't have the name of anyone, but we can find a lot of data about this mother was born in this state, in this municipality, and this was the birth date of the mother, etc., etc. And with this query, I want to look at how many mothers we have per state. Why do I get only one row here? It should show me the 38 rows, but there is. There's something weird on how it was displaying the data. But yes, the Mexico state, which is the capital state, had 1.2 million babies, mothers, and that's a lot. Their privacy may be very protected. But the smallest states only have 15,000 mothers, so their privacy is not that protected. Now, why do we reveal this data? Why are these data sets public? Well, you might want to learn health, how the health of babies compare state by state. So in this query, you can see me doing, I'm going to get the average weight for a baby, the average height for each baby, the ratio between both of them. And I'm also doing some cleanup of the data because this is real data, so it's not 100% clean. So I want to get only babies with a normal height. I don't want babies that measure 1 centimeter. And I want babies with also normal weight between 1 kilo and 6 kilos. And you can find data like this. Like, let me visualize it instead. This is how the weight of the babies and the height of the babies is distributed state by state around Mexico. So you can find this that, yeah, the smaller babies also weigh less, but even for the same height, you can find that these babies are the same. So these babies have the same weight, but some are way taller than the others, and you might wonder why and why things are by state. So that's interesting. But then let's look a little bit of some quasi identifiers. So we have where the baby was born, in what region the baby was born. We have the gender of the baby. And for the mother, let's look at her education and her civil status. Is she married, separated, or not? And I can run a query like this to count my groups. What do we have here? I'm going to do a count of, I'm going to group by state, birth, where the baby was born, the marital status of mother, the education, the gender. And once I'm running all of these counts, let's see how big my groups are. Somehow it's displaying only one row, except when I replace it. But you can see that some places are way bigger than others. And then the question is, what happens when we have groups that have less than 10 people? Now their privacy is under risk, we could say. Let me comment this. Yes. This is how many groups with these variables have less than 10 people. So yeah, we have, for example, we have 405 groups of only one person. For example, someone that was born in Nayarit, who is a widow we don't know their education, and the baby is a female. That group has only one person, and this would mean that k-anonymity is 1. The question is, what do we do when we have an anonymity, those small groups? That's where the hard decisions come. We can remove those groups from the public dataset. Let's remove anything with k-anonymity less than 5. That's pretty normal on research, on some research places. But then you are removing a lot of people of your dataset, and you are removing people from the, especially minorities that then disappear and then are not part of research, and they may really want to be counted and considered when people are designing public policies. You can also do some bucketing, aggregate it, and generalize this data and add it with more, instead of making it really specific, you can remove one of these columns, and then the groups will grow larger. And yeah, so for example, if we were going to delete everyone that was born in Baja California Sur, everyone that has a k-anonymity less than 50 in Baja California Sur, you would be deleting at least 1% of data. So maybe you want to aggregate it instead. And then instead of running this measure as I just did with a SQL query, you may want to automate this. And again, you can go to the API, the DLP API, and tell it, hey, measure the k-anonymity for this data set using these these 4 quasi IDs. And you will get your results. And then you can do a fix like, instead of publishing the age of each person, each individual person, let's round it to the nearest decade. And then your k-anonymity improves. But measuring k-anonymity, that's one of the basic measures that people use, is not enough. So let's take a look at Eldiversity. For example, this group has a k-anonymity of 5. Postgraduate divorcees from Coahuila de Zaragoza, between these years, we have 5 of them. This is good enough. Their anonymity is preserved. But let's look at this other column, hepatitis B. Turns out these 5 women have hepatitis B. And now we're revealing something about them. Even if the group had 5 people, the 5 of them have the same thing, so we're revealing something sensitive. And the measure k-anonymity did not tell us anything about this. So instead, we have this other measure called Eldiversity. Eldiversity will measure how much diversity of sensitive data you have in one group. And you might want to define, we want to have Eldiversity at least to be certain number. And again, you can call the API and ask it, instead of just calling what are your quasi IDs, you can ask for, these are the sensitive IDs that I want, sensitive attributes I want to protect, and I want to measure to have at least some diversity of it in each group. So yes. But there are other measures because k-anonymity, Eldiversity is not enough. Sometimes a k-anonymity of 1 is not a problem. So let's say this is our dataset. Our dataset has only 2 rows. We have one person from this zip code who's a 79-year-old, and we have this other person that's a 42-year-old from this other zip code. K-anonymity is 1 here because we have only 2 people, but their privacy is pretty protected because even though we have only 1 person, we don't know who they are. There's a lot of 79 years old in this zip code. There's a lot of 42 years old in this zip code. This is OK. But is it OK? K-anonymity is 1, but it's not a problem at all. But then turns out that each zip code has a different number of people. There's some statistical risk here. The first zip code here has a population of only 20 people. So if we have only 20 people there and we're talking about the 79-year-old person, we probably can find them. The other one, the 42-year-old, is pretty anonymous within their big zip code, but the other one is not. And you can see we would call this having a Kmap anonymity of 1. And that's not good anymore. But to calculate this, we had to bring some statistical data of how big the population is related to the data we are showing. In my case, the Felipe big data, what's important to know, what's important to measure is how many people are called Felipe versus how many people are called John. Saying that someone is called John, not a problem. Saying that someone is called Felipe reveals a lot about them in a data set like this. How do we increase the Kmap anonymity here? We might want to stop publishing the age. If we don't publish the age, then Kmap goes to 20 because it can be any of these 20 people in this town. K-anonymity is fine. Anonymity is OK. Kmap it would be better. And then that's not enough always. So here, in a data set like this, our Kmap is 1. We have 5 people between 10 and, in this zip code, there are 5 people between 10 and 19 years old in this zip code. So their privacy is not very well protected. The 5 people that live in this place that have these ages, they are all represented in the dataset. Kmap is one. But so instead of publishing the age, we can publish a range. We will publish between 10 and 19. And then Kmap goes up to 5, and we cannot identify which one is which in this dataset. Is this enough? Have we protected the privacy of everyone? Again, there are other measures. For everything that we devise, we can find some risks. And the risk here is, what's this dataset about? What if being in this dataset reveals something about you? For example, this is a dataset of everyone that has been convicted. It doesn't matter if we cannot identify which row corresponds to everyone, but all of them, the 5 kids between 10 and 19, have been convicted. Now we're revealing something about them just because all of them are covered in this dataset, and we call that measure delta presence. And this means delta presence measure that the probability, if you are in the dataset, that is sensitive, and the probability of you being in that dataset, in this case, is 1, because everyone 10 to 15 is in this dataset from this zip code. And again, we might, instead of having buckets of ages of decades, we might want to publish an age that they are between 10 and 39, and then the probability of you being marked by this dataset goes from 1 back to 1/4, and that's much better. And as I was saying, you can do all of these measures with the DLP API. And what's interesting to see is how, for each of these measures, you have to change how you call the API. K-anonymity is really easy. Just tell it what are your quasi-IDs. Eldiversity, your quasi-IDs plus what are your sensitive attributes. For Kmap, now you need to add statistical data, which is the same with delta presence. You need to add information of how big each group is outside of the dataset. What's your attack dataset? The API comes with a lot pre-configured, especially in the US, but you can bring your own statistical datasets. So just to start closing, best practices here with data privacy is, yes, minimize exposure when you're publishing or sharing data, remove sensitive data, and if you don't want to remove everything, do tokenization, generalization, date shifting, but while at the same time measuring how much risk you have in your dataset, deciding to either remove the outliers or bucketize them. So these were some ideas. What I show you here with the New York City taxi dataset and all of these privacy scandals that came with it, even though we love analyzing taxi trips, the city has been, in each iteration, they publish less and less data. You will not find the latitude and longitude for each trip anymore. Now you will find only the zone where people took the trips. So with the data that they're publishing now, I cannot create a visualization like this because I only have zones. And they also remove the hash of the driver, so I cannot see the behavior of each driver anymore, which was interesting if I wanted to talk about policy and how to bring the correct incentives for them to not leave at 4 p.m. And then, yeah, and those are the different iterations. The question is, are we in a better place now having a less rich dataset? Of course, it has less value, but it increases the privacy of people. Where's the sweet spot? That's for us as a society to decide. And we need to balance all of this. I did all of these examples with public datasets, but yes, you will, especially now, you have to be super aware of how you're sharing data within your organization, with other organizations, and you need to run the same kind of analysis when doing this internally. And even if all is fine to share, still, when you're doing machine learning, you want to remove some data to make your algorithms more effective. You can find that we are also working with differential privacy That's also an important topic that I didn't touch today. But even when you're doing differential privacy, before running this, you want to understand your data. You want to scan for PII. You want to redact the data that you don't need. You want to tokenize. And if you only do the differential privacy, you will always have a risk of leaking PII, or you may have regulation risk if there is PII contained in the model, even if it's not displayed in any way. This is how we close the talk. As I said, my name is Felipe Hoffa. You can find me on Twitter. I love ratings. I love the cards. However you feel, please put your card out there. But if you want to tell me anything, I also love comments, and you can use this form. You can find me on Reddit, on Stack Overflow, on Twitter, and I'm very happy to get your questions or talk later if you'd like. Thank you. Great. Any questions out loud? Well, thank you for coming, and let's go have lunch.